All right, number 8. To find all the zeros of this polynomial, it says look at the graph to find the real one. I think the test might be a 4th degree polynomial. I don't know. But it's an x cubed function, so we're going to pull out the real one, and that's going to get us down to what we call a quadratic. And then we're going to hit it with either the quadratic formula. Actually, looking at this one, I probably made this one pretty simplistic. We can probably find the missing 2 zeros by taking square roots. Doesn't look like it's a hard one. You don't have to have a 0 in y2, but maybe. We'll just put it there just in case we have to use the intersect feature. So you were trained to do a zoom 6. So there is one nice answer. It's right there at -2. You see it? X equals -1, -2. So from the graph, the zeros are -2. And we're going to do a little synthetic division with that. Coefficients, acronym again, DMA. We're going to drop the 1, multiply and add, multiply and add, multiply and add, and a 0 was achieved, and that was expected. We're going to interpret remainder constant x squared. We are left with x squared plus 9. We're going to set it equal to 0, not because of that 0, because there are 2 zeros left there. And this one, you can do it through isolation. We're going to subtract 9 from both sides, or shift right, however you want to think about it. The opposite of squaring is a square root. So x is, don't forget the plus or minus symbol, the square root of a -9, which is imaginary. And please do not write I root 9. You know what the square root of 9 is. It's 3. So plus or minus 3 i's. 3i and -3i. Easy peasy lemon squeezy. All right, a polynomial has 4 known zeros, -1, 5, √2 minus 1, and 5 minus 3r. What are its remaining 2 zeros, and what degree is it? So remember the ugly root theorem? It says ugly roots have conjugates. And your ugly roots are that guy and that guy. So the missing zeros are root. Ooh, I about messed that one up. And it's the ugly thing that changes sign. We change the ugly part's sign. So this would actually be -√2 minus 1. Only the ugly piece changes sign. And the other one's going to be 5 plus 3i. Now, what is the degree of the polynomial? So we have 1, 2, 3, 4, 5 zeros, which means it's x to the 5th. It's a 5th degree. It's a 5th degree polynomial. All right, small bonus. What was the relationship between those two given zeros and their counterparts? Well, I already used the word. They were conjugates. All right, how many zeros, real or imaginary, does this polynomial have? So this is the fundamental theorem of algebra. It's a pretty simple theorem. It is the fundamental theorem. I actually gave you a watered down version. It says x to the n has n solutions. Plain and simple. So I'm going to focus on the power function, the first thing I see in standard form, and I'm going to look at that exponent. So this polynomial has 108 solutions. And I swear to you, 20%, 25% of my students will miss this. And it ain't me. That's not a reflection on me. That's a reflection on you. All right, determine the power function, the zeros, including the multiplicity of f of x equals 4x squared times x minus 1 cubed times x plus 2 times 2x minus 1 to the 4th times x squared plus 1 squared. Then classify the 0 as real or imaginary and talk about whether it crosses or touch. So the power function here, you're going to do some near math. You've got the first factor. We're just going to take a look at it. We're going to get the x from each factor. You got a 4x squared. Here you have an x that gets cubed. I don't know why it's writing so bad. From this guy, you have an x. From this guy, you have a 2x, but that 2x has to be raised to the 4th power. And here you have an x squared squared. Now this twin is harder than the real test, but I'm grabbing the x's from each factor, okay? So let's focus on our x's. We have a square, we have a cube, that makes 5. A 1, that makes 6. A 4, that makes 10. And here, 2 times 2 is 4, we're at 14. I'm going to run through that again. 2 plus 3 is 5, plus 1 is 6, plus 4 is 10. We multiply those together. We get another 4, 14. Now we've got a 4. Here we have a 2 to the 4th. 2 to the 4th should be 16. 4 times 16, 64. Power function is 64x to the 14th. All right, your zeros, you take each factor and you set them equal to 0. 4x squared is a 0. X is 0. Happens twice. Even touches. Multiplicity is even, we touch. All right, here's a 0. X minus 1 is a 0. X is 1. Multiplicity, 3. We cross, because that's odd. Looking at the exponents, kids. Looking at the exponents. X plus 2 is a factor, so x is negative 2. The exponent here wasn't understood 1. That's a multiplicity. It is odd. That is a cross. 0, 4. 2x minus 1 is a 0. 2 steps. 2x is 1. X is a half. Multiplicity was a 4. That's even. We touch. All right, now I'm looking at the last one here, which is x squared plus 1, all squared. We have x squared plus 1 is 0. X squared is negative 1. X is plus or minus the root of negative 1, which is I. So one of your 0 is I, and the other 0 is negative I. But they both happened 2 times, and they are imaginary. Nice little problem there, isn't it? Going to be missed by a lot of kids. It is. 12. Some of you have talked about this classes, and some of my classes have talked about this one, and some of them I haven't. It's a really easy theorem. I just kind of ran out of time, so I didn't get talked to about it like I should have. All right, so the theorem states that a polynomial x to the n has at most n minus 1 turning points. So to go the other way around, the degree of the polynomial, let me say the least degree, is the number of turning points plus 1. So it's going to be 129 plus 1, which is 130. It's at least a 130th degree polynomial. So, you know, if I haven't shown you that theorem, I'm just going to make something up. Let's go with a good old quadratic. Now, you know what a quadratic looks like. It's a parabola. And this one has 1 turning point. It turns right there. It goes from decreasing to increasing. Now, it was a 2nd degree polynomial, 1 turning point. Let's take a look at maybe a quartic. That'd be a 4th degree. A 4th degree polynomial, 4th degree can have at most 3 turning points, and I didn't do a good job on this one, so let me add some more stuff in. Doesn't really show off the theorem very well. Let's say plus 3x cubed minus 2x. And hopefully that's enough to show you how many turning points it has. This is a 4th degree polynomial. It will have at most 3 turning points. 1, 2, 3. You see them? 1, 2, 3. So there's an easy one. Be missed by a lot of kids. 13, we missed by a whole lot of kids. Below is a graph of f of x. Write the equation of f of x in factored form. Don't forget about a. So what we're going to do is we're going to take our zeros. We're going to find our zeros. We're also going to talk about multiplicity, but these are all, there's only one of them that touches. They are x equals -3, x equals -1, x equals 0. There's a reason I'm putting on a different line here. And x equals 2. Now, -3, -1, and 2 all cross the x-axis. That means they happen an odd number of times. That's a big deal. Now, the smallest odd number is 1. So we say the multiplicity is 1. X equals 0 touches the x-axis. So that means we happen an even number of times. And the smallest even number is 2. It's actually 0, oddly enough. But anyways, so the multiplicity is 2. I'm going to pause real quick. I got a headache. I can get some Tylenol. BRB. All right, so I'm back. All right, so let's talk about what we have here. We have some polynomial, we'll call her f of x. There's always an a. X equals -3 is a 0. X plus 3 is a factor. X equals -1 is a 0. X plus 1 is a factor. X equals 2 is a 0. X minus 2 is a factor. The exponents are all understood ones. Now, x equals 0. Let's talk about that. X equals 0 is a 0. X minus 0 is a factor. But x minus 0 is just x. Its multiplicity was a 2. Happens twice. Cool. Now, how do I find a? Well, to find a, I need a third. Okay, anyways, I went over to Desmos and I replotted this thing. And it's a hideous problem, but it's also a twin. Keep that in mind. Everywhere I see an x, I get to be this number. I get to be this number. Everywhere I get to see a y, I get to be this number. So 6.32936 is a. We're going to add 3. That would be 4.49117. We're going to add 1. That'd be 2.49117. And we're going to take away 2. That'd be -50883. And we're just going to write it down and square it. 1.49117 squared. And let's see what the TI-84 says that is. So all these funny numbers right here, I'm going to type in. 4.49117 times 2.49117 times -0.50883 times, and I know these are hideous, your quiz won't be that bad, so don't get scared. That's what's attached to a. A times -12.6587 and some change. And that equals 6.32936. The next move would be to divide that -12 and some change out, right? So if you're playing along with a calculator, it's not that hard. 6.32936 divided by that, bruh, is going to be roughly -1/2, and that's what a is. So the full polynomial is that f of x is -1/2 of x plus 3 times x plus 1 times x minus 2 times x squared, which is probably going to be over here. All right, I'm going to stop right there and get restarted for the next video in just a moment.